In section 15.3. In this section, we're going to talk about conservative vector fields and independence of path. So we're actually going to start with an example. We have a given vector field, f of xy is xi plus yj, and we want to find the line integral of f dr from 0, 0 to 1, 1 along three different paths. So we're going to ultimately go from 0, 0 to 1, 1, but in three different ways. So the first way we want to do it is just along the straight line of y equals x. So first off, let's create our parameterization for that curve. So let's find, say, an r of t. Well, we need an x and a y, so we need like what is x of t and what is y of t for our parameterization, and we could make this fairly simply where we could say just let x be t and then notice y equals x, so that would mean that y is also t. So then this would be the curve tt, and this would be for t ranges from 0 to 1, to have it go from 0, 0 to 1, 1. To do that line integral, remember we're going to need r prime of t. So this would be the derivative with respect to t, which will just be 1, 1. So then my line integral over c of f dr is going to be the integral. T went from 0 to 1. F is the, we can write it down here, right? F of xy, if I put it in component form, is xy. So we're going to plug in our x of t and y of t. So that's going to be tt. And we're going to dot that with r prime, which was 1, 1 dt. So this is going to be the integral from 0 to 1. We'll have t plus t dt. So then we get the integral 0 to 1 of 2t dt, which is going to be t squared is what t will do. So we'll end up with, right, 2t squared over 2, we'll just simplify to t squared, and then evaluating that from 0 to 1 gives us 1. So along this path, the line integral is a 1. Let's look at another path. So let's instead now say that we want to go from 0, 0 along the path y equals square root of x. So again, we're going to need another parameterization. So we're going to need an x of t and a y of t, and all of these are fairly simple, where if we just let x be t, where t goes from 0 to 1, then x is going to do what we need, and then y, we'll use our function up here, which was square root x, so it'll be square root of t. So then r of t is t comma square root t. F, remember, was xy for this one. R prime we can find is going to be 1, and then for the square root of t, bring down the power, so it'll be 1/2, and then we're going to reduce the power on t by 1, so it'll be 1 over 2 square root t. And then when we do our integral, we're going to do the integral from 0 to 1 of f dotted with r prime of t dt. So this is the integral 0 to 1. So when we plug into f, x was t, y was square root t. Oops, not dt yet. So we're going to dot that with the 1 comma 1 over 2 square root t dt. So that gives the integral 0 to 1. We have t times 1, so t. And then we're going to have square root t times 1/2 square root, 1/2 over square root t. So the square root t's are going to cancel out either way. So we're left with 1/2 dt. So then when we integrate t, it'll go to t squared over 2. And then the 1/2 will gain a t. And we're going to evaluate that from 0 to 1. So plugging in 1, we get 1/2 plus 1/2. And then plugging in 0, we get 0. So really we just have that half plus a half, and we get 1, which is interesting. Let's try one more. Let's try doing it along the curve y equals x squared. So this time now we're going to have x of t is t, y of t is t squared for t goes from 0 to 1. So r of t is t squared. F is still xy. R prime this time is 1, 2t. So now we'll do the integral 0 to 1 of f dr is going to be the integral from 0 to 1 of t, t squared, which is f with the x and the y plugged in, and then dotted with 1, 2t. So that's going to be the integral 0 to 1. We'll have t plus 2t cubed dt. So in that one, we're going to end up getting t squared over 2. And then we're going to bump t cubed up to a t to the 4th. And then we'll divide by 4, which will cancel partially with the 2. So we'll be left with a t to the 4th over 2. Evaluate that from 0 to 1. Plugging in 1, we get a half plus a half. Plugging in 0, we get 0. So again, we get 1. So every single time we've gotten that the line integral of f going from 0 to 1 is 1. So it's a very interesting thing. Notice the line integral is the same for all 3 paths. And this is the idea that we want to focus on in this new section is why is it that this is happening and when is it going to happen? So this is this idea of independence of path. So regardless of what path we pick, we end up getting the same line integral. We want to figure out when is that going to be the case.